Hi guys, in this video we're going to have a look at distance time graphs, okay? So, let's get a few things sorted out before we get started on some of the more juicier questions. I have four little mini distance time graphs here. The time is along the x-axis and the distance is going up the y-axis, okay? So distance time graphs, that's what they would look like. Now, if you have straight lines, that is a constant speed. Whatever the distance time is referring to, whether it be a car, whether it be a boat, whether it be someone walking, whatever it is, a straight line shows a constant speed. And the steeper the line, or the steeper the straight line, in other words, if it has a higher gradient, the faster it is. So this line here would be faster than this line here. Both are constant speeds, but that one's got a smaller gradient, so that's slower than this one. Okay, so that's the first thing to bear in mind. If it's not a straight line, like this one here, a nice curve, this is what will be acceleration. Okay, so it starts off slow and gets quicker and quicker and quicker and quicker and quicker. So if you see a curve, that's acceleration. Obviously, if it goes the other way, it shows it's slowing down. Obviously, it's deacceleration. Okay, so there's a difference: straight line, constant speed, curved, acceleration. The next thing is what it means when it's a flat line. So here we have it travelling at a constant speed, then it stops, and it's a flat line. Now if it's a flat line, in other words, the distance stays the same, it means that whatever is going on, whether it be walking, driving, or whatever, they've stopped. They're stationary. They are not moving anywhere. Okay? And of course, this bit here they would be carrying on their journey at a constant speed again. Now this one here is very similar to this one, but there's one big difference. Here they're travelling at a constant speed, that's the same. They are stationary, so not moving, but this time they come back. Again, it's a constant speed, but they are returning to their starting point. So the distance is reducing because they're returning home. So an example might be you are going to the shops, you spend some time at the shops, and then you come home again. Okay, this one here might be the journey to the shops. So you might go part of the journey, you might stop at a petrol station, but then carry on going to your destination. Okay, so if you see it returning, that's all it means, is basically you are returning to the starting point. In most questions, it will be returning home, depending on the context. Okay, so there's a few little basic things there to describe what a distance time graph would potentially look like and the context around it. Now let's have a look at some questions. So here I have my little mini distance time graph. So time's in hours and the distance is in kilometers. Work out the speed for the first part of the journey. So if I'm working out the distance, speed, time, check out that video if you need to. But remember, we always draw our little triangle, D and then S and then T. And if I want the speed, it's the distance divided by the time. So let's work out the distance and then work out the time. So the distance is along here. It starts from 0 and the first part of the journey is from this point to this point. So I start off at 0 and they've gone 20. So 20 kilometers divided by the time, and the time is down here, and it's broken, each hour is broken up into 4, so it's 1¼ hours. Okay, so I need to do 20 divided by 1¼ or 1.25. So let's get the old calculator out. Divided by, I'm just going to show you this again just in case you weren't aware of it. If you're using a mixed fraction, we press Shift and press the fraction button so we get the mixed fraction. I'll just come a bit closer. We get the mixed fraction option here. Whatever you do, do not put 1 and then press the fraction button. It will not work. Okay, so let's fill this in. 20 divided by 1¼ Of course, you can use the decimal if you want. 20 divided by 1.25. You're going to get the same answer, which is 16. Don't forget the units. It says the speed. Well, it's kilometers per hour. Okay. How long were they stationary? So remember, stationary is when it's a nice flat line like so. So from this point to this point, they were stationary. That's the only flat bit. And as I said, each hour is split into 4, 1 square there. So it's ¼ hour, or obviously 15 minutes. Okay, either one would be absolutely fine, unless it specifies it wants it in a particular unit, but otherwise it's fine. What was the average speed of the whole journey? Okay, so again, I want the speed, so it's going to be the distance divided by the time. But what was the whole distance? Well, the whole distance started at 0. This is the whole journey, and it ended here, which we go across is 60. So the whole distance was 60 kilometers. The whole time was 2 hours. So 60 divided by 2 is 30. And the speed again is kilometers per hour. Okay, so that's a very basic distance time one that you can expect to see. So let's have a look at another example, which I have here. So ever so slightly more complicated, but only just. Okay, let's have a look at these questions. Work out the total average speed. And this is where people will make mistakes, because they'll go, right, I need the distance, and they'll go, well, from 0 to 10 is 10. Lovely. Okay, for that point there. Then I've go from 10 to 50, which is 40. So they'll go, okay, I've gone 50. But you do have to include this travel time here. Even though it's coming back home, doesn't matter. It's still part of the distance that's been travelled. So you'll have 10 for this bit. You'll have 40 for this bit. And it goes from 50 to 0, so it's travelled 50. Okay, so 10 plus 40 plus 50 is 100. In this case, now we're in miles. Divided by the time, well, again, it's in hours, so it's taken them 10 hours in total. So 100 divided by 10 is 10, and then, as I said, miles per hour. Okay, so just be very careful. You do include that return journey as part of the distance that's been travelled. How long were they not moving? So again, I'm looking for my stationary points here. So I've not been moving from this bit here, but I've also, in the journey, been stationary there. So just be careful, just make sure you get all of it together. Each square in this case is worth 1 hour. So 1 hour, 2 hours, 3 hours is how long I've been stationary for. Okay, part C. Work out the average speed for the first 4 hours. So here I go, the first 4 hours is this bit here. So speed is the distance, which is 10 in this case, divided by 4, because that's the first 4 hours. Excuse me. Okay, so 10 divided by 4 is the same as 5 divided by 2, which is 2.5, and the speed is miles per hour again. Distance is miles, time is hours, so it's miles per hour, so 2.5. Very slow part of the journey there. And the last question for this one. Between the hours of 9 and 10, the gradient is negative. In other words, it's decreasing. Okay, it's decreasing. These are all increasing, they're going up. This one is decreasing. What does this tell you about the speed? Now, in this case, it doesn't tell us anything about the speed. Okay, the speed, the distance travelled is 50, the time is 1 hour, so it would still be 50 miles per hour. However, what it does tell us is that it's change of direction, it's coming home. Okay, so as far as the speed's concerned, it doesn't tell us anything, so it doesn't tell us, it tells us nothing. Okay, all it does tell us is the direction, which is coming home. So just a little point there, just in case they do bring that up in an exam. Okay, so it doesn't affect the speed if the gradient is negative. All it does is tell you the direction has changed. Okay, so that's that one. And the final thing we're going to do is have a look at how you draw one yourself. So here is the question, okay, and you just take it step by step by step. Definitely get a ruler, definitely get a pencil. In case you make a mistake, you can obviously rub it out, and a ruler makes this nice and neat, and you will lose marks for accuracy if you don't use a ruler, so definitely have one. Right, let's get going. I leave home, so I'm starting at home, heading to a shopping centre. I leave home travelling at 65 miles per hour for 2 hours. So I need to work out the distance, because that's what the y-axis is. So quick draw of my little triangle. Distance, speed, time, happy days. If I want the distance, it's speed times the time. So it's going to be 65 times by 2 hours is 130 miles. In 2 hours. Okay, so 2 hours is here, and I've gone 130 miles. And it's constant average speed, no acceleration here, so it's a nice straight line, like so. Okay, I stop for 30 minutes at a petrol station. Now each hour is 2 squares, which means 30 minutes, which is half an hour, will be 1 square. So there's me stopping. I'm going to put a little point there. There's me stopping for 30 minutes. I carry on towards the shopping centre, so I'm still moving away, so I'm still going to be going up at 30 miles per hour for 1 hour. So how far is that? Well, it's just 30 times 1, so 30 miles in 1 hour. So remember, 1 hour is 2 squares, and I've gone 30 miles. So if I was on 130, I'm going to add another 30 to be on 160. Again, constant speed, so nice straight line. I spend an hour and a half in the shopping centre. So hour and a half, so 30 minutes. So the half is 1 square, and then another hour is 2 squares. So that's 3 in total, like so, to get to there. And the journey home, so I'm coming back now, coming back to the start, takes 2.5 hours. Well, if I'm on 5, 2.5 would be 6, 7.5. So it would be that point there. So I join those up like so to show my return journey. Okay, let's just double check, make sure you've done this right. I leave home travelling at 65 miles per hour for 2 hours. That was 130 miles, so 2 hours at 130. Lovely. I stop for 30 minutes, which was 1 square. I carry on towards the shopping centre where I do 30 miles in 1 hour. So there's my extra 30 in 1 hour. I spend an hour and a half, so 30 minutes and an hour. And then I come home in 2.5 hours, so I'm on 5 hours. That'll be 7.5 hours, nice straight line, happy days. Okay, so that's how you would draw a distance time graph. Hopefully that helps, guys, and addresses any particular error issues or any misconceptions you might have or errors you've previously made. Thanks for watching.